Alright, so I think you've already seen pendulum problems with energy analysis before, but this video is just to make it explicit if you struggled with those problems. The easiest calculations are at the equilibrium point or amplitudes because all of the energy is in one bucket. If we were looking at the equilibrium point, well, we could call this h equals 0, so all of the energy is in kinetic. And up here, it's not moving at its highest point, so all of the energy is in potential energy of gravitation. So my little diagram looks like this. My two snapshots are at the amplitude and equilibrium. Let's say that I do want to try and figure out the velocity there at the very bottom. There's just a clever little trick that I want to show you guys in breaking this thing up. The length is always L, so whether I look at that snapshot or that snapshot, the length of the pendulum is L. I'm going to define this green part as L cosine of theta by trig. This is L, that's theta, then green is L cosine of theta. The height for the potential energy is from wherever I call 0. Now this is my h equals 0 line, let me just define that. H equals 0. So when I'm up here, I have gravitational potential energy due to this change in height, so I need to try and find h. Well, if this is L and that's L cosine of theta, then I could write an expression L cosine of theta plus h is equal to the length of the pendulum. I could rearrange that for h and write something in this terms. Notice that I just pulled out an L from each term and put 1 minus cosine theta in parentheses. So my energy expression is UGI equals KF, and then I followed the terms through where I plugged in for H, and I could rearrange this to solve for velocity. And if you have velocity at the bottom, you could change this around to solve for H. But this is the energy in a pendulum. Notice if I took a snapshot right here, while the thing was swinging down, it has some potential energy and kinetic energy, which just makes the calculations a bit more messy, but we could do it because energy is conserved. So if I know the energy in the pendulum at that point, I know the total energy in the pendulum at any point during the swings, supposing that it doesn't lose energy due to air resistance or friction. That's that. See you soon.